A prism of refractive index n1 and another of refractive index n2 are stuck together without a gap as shown in the figure. The angles of the prism are the angles of the prism are given over here, and n1 and n2 depend on the lambda. The wavelength of the light is given over here. Okay, the wavelength is in nanometer. We have to first calculate the wavelength lambda naught, for which the rays incident on the angle BC pass through without bending at the interface, okay, at any given angle. And second thing, we have to calculate the value of angle of incidence such that the minimum deviation is produced by the combination of the prism since minimum. Okay, so let us calculate the first thing. Now it is given that if I consider the CB interface, the ray passes somewhat like this and it will pass undeviated. Suppose कि मान लेते हैं यहाँ पे angle of incidence 0 रहेगा, so angle of refraction will also be 0, so the ray will not bend, that is the deviation will be equal to 0. But this is a special case. Now it is very much specified that it passes through the interface BC at any angle such that there is no deviation. It means that for any angle there is no deviation over here. This is possible only in one case, when over here refractive index of the prism will be equal to refractive index of the glass slab. Okay, only in this case, that is the refractive index of the first prism is equal to the refractive index of the second. Only in that case the ray will pass undeflected at any given angle. Okay, this is only a particular case. So when I substitute the value, it will be equal to 1.2 plus 10.8 into 10 raised to minus 10 to into 10 raised to 4 divided by lambda square will be equal to 1.45 plus 1.8 into 10 raised to 4 divided by lambda square. I will shift this term on the left hand side and shift this term on the right hand side over here. So it will be equal to 1.45 minus 1.2 will be equal to 0.25. Okay, it will be equal to, I can take 10 raised to 4 divided by lambda square common, 10.8 minus 1.8 will be equal to 9. So basically lambda square will come out to be 36 into 10 raised to 4. Okay, so lambda over here will come out to be 6 into 10 raised to 2 nanometer, because it is specified that the lambda over here is in nanometer. Okay, the lambda over here is in nanometer. So now over here lambda or lambda naught, okay, let me take this as lambda naught because it is specified only at a particular wavelength. Both the refractive indices will be same. Okay, so I got the value of lambda naught over here. Let us find out the first refractive index n1 over here. When I substitute the value, n1 over here will be equal to 1.2 plus 10.8 into 10 raised to 4 divided by lambda. I will substitute it in nanometer. It will be equal to 6 into 10 raised to 2. Okay, so when I substitute the value, over here lambda square, so it will be 36 or 6 into 10 raised to 2 the whole square. Okay, so when I square this term, it will be equal to 10.8 into 10 raised to 4 divided by 36 into 10 raised to 4. So this will come out to be, when I calculate the value, 10.8 divided by 36 will be equal to 0.3. So the refractive index of the first will be equal to 1.2 plus 0.3 will be equal to 1.5. So the refractive index of the first prism will be equal to 1.5. Okay, now and the end of the second prism also it will remain same, because over here at lambda naught both the refractive indices are same. Now it is given that we have to find out the angle of incidence such that okay, at the angle of incidence at AC such that the combination gives me zero deviation. Okay, now the combination, for this combination, now I can consider both this prism as a single prism, because over here both the refractive indices are same. So actually the prism will look somewhat like this. Okay, the prism will look somewhat like this, this being the angle of the prism A. Okay, I do not know this angle yet. So this is 60 degree, this is 40 plus 20 which is equal to 60 degree. So the angle of the prism has to be 60 degree. So the angle of the prism over here is equal to 60 degree. For minimum deviation, R1 will be equal to R2 will be equal to A by 2. Okay, that is the R1 is equal to 60 by 2 which is equal to 30 degree. Okay, now I will substitute the formula of the mu is equal to sin I by sin R. Okay, or in this case it will be equal to sin R1. So mu over here is equal to 1.5. I1 sin I1 I do not know the value. Sin R1 is equal to sin 30 degree which is equal to half. So basically sin I will come out to be 0.75, or I can say that I will be equal to sin inverse 0.75. This will be the angle of incidence for which the minimum deviation occurs for the combination.